Well, let's do something crazy here. What about an elevator that accelerates downward at 9.8 meters per second per second? What will the scale read now? Well, we go through the same process. Sum of the forces equal ma after we draw our free body diagram. Normal force minus the weight equals ma. Normal force equals ma plus mg. And the acceleration is negative 9.8 since it's downward and we're keeping up positive. And so you can see it's going to come out to 0. So the scale won't read anything. And if the snowman were to let go of his broom and his hat in this situation, they might float around the elevator cabin as he is in free fall. And this would be true whether you're increasing speed on the way down in free fall or if the elevator cable were to break as you're going up, you would also have a 0 scale reading as you're decreasing speed on your way up. That surprises people. Let's look at a situation. Well, let's look at another ridiculous case here. Let's say the elevator had a downward acceleration of 19.6 meters per second. What would the scale read then? And so we're going to keep the same coordinate system. Even though the acceleration is down, we'll make up positive. And the same free body diagram, same equation we've been seeing for the elevator, solving for the normal force, which is the scale reading, and knowing the acceleration is negative since we made up positive, we find out that the normal force is equal to the snowman's weight. And so it's just like when he's at rest or going constant velocity. However, what's this minus sign mean? What's the significance of that? Anybody? The scale reads the same, but what will be different? The scale is on the ceiling now. So after a little bit of rearranging, the snowman could be sitting on the scale and it would read 490 newtons, but since it's pointing down, the normal force is down, we get that negative. By snowman. You would have to pull harder with the cable than gravity's pulling down to get an acceleration like this, and elevators just don't work that way. Well, let's look at one more example. This is what you'll be asked to do in the lab. And so in this case, we're given the scale reading, and we want to figure out what the acceleration is. And so the snowman mass is still 50 kilograms. Free body diagram still the same. Sum of the forces equal ma. Normal force minus the weight equals ma. Now we solve for the acceleration. And so it's the normal force minus the weight. Notice the brackets there, the parentheses, very important, over the mass. And so putting in the given scale reading, which is less than his weight, so you might suspect a negative acceleration, or you might just see it's over there on the bottom left of the slide. We get an acceleration of negative 1.8 meters per second. And so he's either speeding up on the way down or slowing down on the way up. Would both work for that. Let's take a look at a graph of acceleration versus time taken on an elevator. And you'll be looking at something like this pretty soon in the lab. And what we want to do is try and figure out what was going on the elevator as time went on here. And so it's not very easy to do, and it's actually impossible to do unless you're told that the elevator starts from rest. Otherwise, we don't know what this 0 acceleration means. It could be moving constant velocity either up or down too. So we're told it started from rest, and region 1 then means the elevator is at rest. And so what's going to happen here at region 2, the acceleration goes positive, and so we know that since we're at rest, we have to be speeding up now, and we're speeding up on the way up. That's one of the choices for positive acceleration. Then the acceleration goes to 0. Some people might be tempted to say, oh, so it must be stopped. But we haven't slowed down yet. There's no negative acceleration yet. And so 0 acceleration has to be moving at constant velocity. So this is the elevator cruising past floors. Then it starts to reach the floor it wants to stop at, so now it's going to have to slow down and stop. So we know 4, we are decreasing speed and we're still on the way up. Then we come to a stop, there's a little wiggle there, and now the acceleration is 0. So we know 5 is the elevator is at rest, only because we've worked out this history. If you just look at region 5 without working out the history, you can't tell what's going on here. It could be constant velocity. Now we get a negative acceleration. Well, we know it's not the same as over here. We're not slowing down on the way up. In this case, we're speeding up on the way down, increasing speed on the way down. Then 0 acceleration, we now know that we're not going to fall for that being at rest. We know the elevator has reached its constant cruising velocity on the way down, and so that's another constant velocity region. And then here the acceleration goes positive, but we're already moving. So we know it can't be the elevator speeding up. Here the elevator is decreasing its speed, and we're on the way down. And so that's region 8. And then we know anytime an elevator starts to slow down, the next thing it's going to do is stop. And so region 9 is another elevator at rest part. And so on the lab, you'll look at something similar to this, and hopefully this will help you answer those questions. Not easy. And so what about this lab? Well, I took a force probe and hooked it to my laptop and went to the prune yard tower. Hanging from the force probe is a mass, and you'll figure out what that mass is because you'll be given the force versus time data, and you'll be told the elevator starts from rest on the first floor, so you can take the data from the scale and figure out what the mass is. Then you're going to use Newton's second law to figure out what the acceleration versus time graph looks like, and the instructions in the lab will help you with that. Once you have the acceleration time graph, now you can use kinematics to figure out what the velocity is from the acceleration, and once you have the velocity, you should be able to figure out what the position is from the velocity. And knowing that the elevator started at rest on floor 1, you should be able to determine what floors I stopped at when I collected this data. You can actually do that pretty easily just looking at the velocity graph. The position graph will help you verify your answers. Very key that you follow directions in this lab, and you will succeed. But pay close attention to the directions, read them, and follow them. And here's some fun things to do on an elevator. I'm going to post these notes online, and so you can read these at your leisure. I added number 20 here. I found this picture where they painted the floor of the elevator to look like an empty shaft, and this guy's standing there. I'd like to try that elevator sometime. And so good luck with the lab. We'll see you then.